this is pre-calc lesson 1.7, modeling with functions. Basically, we'll be writing equations, kind of going through some of the assignment with you. So I would like you to follow along, write down the ones as I go, working them with me. Here we go. Number 6, the area of a triangle whose altitude is 2 more than its base length, x. So what we're going to want to do there is write the formula for area of a triangle. So half times base, which would be x, times height. Well, height is altitude, same thing. 2 more than its base. So x plus 2. You can leave it like that. 12. The total cost is 28,000 increased by 9%. Well, to write that as a decimal, we're going to go 0.09. But remember, when you're increasing and you're going to multiply, you want to put that 1 in front. So 28,000 increased by 9% would be 28,000 times 1.09 plus 1985 for each one purchased. Okay? So each item would be X. All right. Mark received a 3.5% salary increase. His salary after the raise was $36,432. So salary after the raise was $36,432. To find his new salary, we want to find his old salary. So X times his raise. Well, that would be 0.035 if we write that as a decimal. But remember, it was an increase. So we want to put a 1 in front of that. So you take 36,432 divided by 1.035. 35,200 would have been his old salary before the raise. All right. 26. On their 560 mile per hour trip, so distance equals speed times time, the Bruins basketball team spent 2 more hours on interstate than they did on local highways. They averaged 45 miles per hour on local and 55 on interstate. So 45 times local, so speed times time, plus on the interstate it was 55, and they spent 2 more hours than they did on local. So we can solve that for x. So I got 45x plus, I have to distribute, 55x plus 110. So that's 45 plus 55 is 100x. I'm going to subtract 110 from over here. So it gives me 450 equals 100x. Divide by 100. So x would be local. So we'll be looking at about 4.5 hours on the local. All right. Cell phones. From 96 to 97, the number of cell phone antennas in the U.S. grew from 30,000 to change to 51,000 and change. What percentage increase would be in that one period? Well, so we have to figure out, to do a percentage increase, we take the change divided by the original. So the change is 51,600 minus 30,045. So the change is 21,555 divided by the original, which would have been the 1996. So we take 21,555 divided by 30,045, about a 71.7% increase. Quite a bit. All right. A square of side x inches is cut out of each corner of a 10 by 18 piece of cardboard and the sides are folded up. Write the volume of the box as a function of x. All right, so we've got a box here. And then we're going to cut out each corner. Okay, so this is 10, this is 18, and these are all x on all these little side pieces. Okay, so from here to here would actually be 10 minus 2x, and from here to here would be 18 minus 2x. So to find the volume, we take length times width, and then the height of the box would be x, because that's those corners. So we can just write that 18 minus 2x times 10 minus 2x times x. Okay? So to find the domain here, well, this is a cubic function. So our domain would be all real numbers, but because we are doing an application problem, we're not going to have a negative value for the height. So we want x to be greater than or equal to 0. We at least want to have something that's a little bit bigger. All right. Also, think about the function itself. If I put 9 into that first part, that makes it 0. And if I put 5 into that second part, that makes it 0. So we know we're going to want to be somewhere between 5 and 9, because that'll make that negative if we go above that, and we can't have a negative volume. So let's go ahead and graph that on the old Desmos. So we got 18 minus 2x times 10 minus 2x times x. All right. So there we go. So if you're looking now, you can kind of see right here. That gives us our maximum volume. It's right there. So we would want to make our volume, or our x length, 2.06. 2.06 inches would give us our maximum volume, and that falls between, I'm sorry, this should be 0 to 9. That falls in our practical domain. That doesn't make either one of those 0, so we have to be between 0 and 9. So 2.06 inches. All right. Renee's decorating service recommends putting a border on the top of 4 walls in a dining room that is 3 feet longer than it is wide. Find the dimensions of the room if the total length of the border is 54. Well, this is the width. X plus 3 is the length. So this would be x plus 3, and this would be x. So we want the perimeter to be 54. So if I add all those sides up, that gives me 4x plus 6 equals 54. So 4x equals 48. So x equals 12. So x is 12. X plus 3 would be 15. So her dimensions of the room would be 12 by 15. Okay? All right. The Buster Green Shoe Company determines the annual cost of making X pairs of one type of shoe is $30 per pair plus $1,000 in fixed overhead costs. Each pair of shoes at manufacturer is sold wholesale for $50. A. Find an equation that models the cost of producing X pairs of shoes. Well, cost is going to be 100,000 plus $30 per pair. Okay. B, find the equation that models the revenue produced. Well, we sell them for $50 per pair. How many shoes must be sold to break even? Okay. Well, I'd want to set those equal. So then I would subtract 30x. So that gives me 100,000 equals 20x. And I divide by 20. 100,000 divided by 20 is 500. So I would have to sell 500 pairs of shoes to break even. If we were to graph A and B, we could do that on Desmos, but the graphical interpretation would just be where the lines intersect. The intersection point is where they would be equal. Okay?